Okay, so now we're going to start chapter 2 in chem, and that's on the standards of measurement. Because when you're doing chemistry experiments, you do a lot of, you collect a lot of data, you do a lot of measurements, and so there's standards to make sure that your measurements are accurate and precise and things like that. So we're going to talk about all that in this chapter. Okay. One of the things remember about doing calculations, you use what they call scientific notation. And scientific notation is a way of writing a really big number or a really small number in a compact form. And really what you do is you have to make sure when you write it in scientific notation that the decimal is after the first whole number. You don't want it back here or in here. It has to be right here. And then this is raised to the power. So if I really wanted to write this number as, not in scientific notation, I'd move this decimal over 8 places. So I'd go 1, 2, 3, and then I'd add 5 zeros. And that's this number when it's not in scientific notation. Okay. So again, the methods is you move the decimal in the original number so that it's located after the first non-zero number. So right here. Then you count how many places you moved it over, and that's that power times 10 to the what. So you can do that when you're working with really big numbers or really small numbers. Small numbers, then, if it was like, 0.000000956, 9.56, and then times 10 to the, if I had to move it over 7 places, -7. So it's an easy way of doing, collecting numbers or working with data that's either really large or really small. Okay, so if I were to write this in scientific notation, I'd go 1, 2, 3, 4. So it'd be 4.23, and since I had to move it over 4 places, but now in this direction, it'd be -4. Okay, so again, place your decimal there, and the decimal had to be moved 4 places. Because it's a number less than 1, it's going to be negative. So 4.23 times 10 to the -4th. And again, just count 1, 2, 3, 4. Okay, so 4.23 times 10 to the -4th. So if it's a number greater than 1, your exponent is going to be positive. If it's a number less than 1, your exponent is going to be negative. Okay, so in this one, what is the correct scientific notation for the number 353,000? Okay, we go 1, 2, 3, 4, 5, right there. So it'd be 3.53 times 10 to the 5th. And I got it right. Yeah. Okay. Whenever you're doing measurements, there's different types of measurements you can do. Okay. Here we have examples: 1 cup, 3 eggs, 5 molecules, etc. Those are what they call quantitative. It means it's a quantity. It's a number. Okay. And in chemistry, we tend to take a lot of quantitative measurements. The mass, the volume, the density, we calculate things like that. But so if it's an actual quantity, a number, it's called a quantitative measurement. Okay. Here's another example: 50 kilometers. And when you have a quantitative, you always have to have a unit. So like on the top, 1 cup, we have a cup. 3 eggs. Okay. It could be, 200 seconds. You're going to have a unit afterwards because that's a measurement with a number. Okay. Every measurement, you have an instrument that takes that measurement for you. Like, for instance, if we're doing mass, we put it on a scale. Okay. And sometimes you have to do a little estimation. Okay. Here's an example of a thermometer. Okay. So it goes, here's 20 and here's 30. And so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 marks. So we know each one of these is 1. Okay, so we know it's 21 for sure, but it goes a little bit past. So that's your estimation. This person says it's 21.2. You might say it's 21.1. But when you take a measurement, what they're called significant figures, and it's the ones you know for sure, the 21, and then you get to estimate 1. So 21.2, that has 3 significant figures. The last one you estimated, but the other 2 are certain. Okay, so now when you start doing calculations with those, it's really important to know what the significant figures are, because when you do a calculation, your answer has to be rounded in the proper amount of significant figures. Okay, so numerical values from measurements, they're never exact. Okay, They're as exact as the instrument that you use to take them. Okay, so you have some degree of uncertainty. Like on that last one, the last 0.2, I might say 0.1, somebody else might say 0.3. Okay, the one thing you could not do is say 21.25 because you know for sure the 21, but you don't know the rest of it. So that you get only one estimation, and estimation. You don't get more than one. Okay, so it's all the ones you know for sure, and then you get to add one. Okay, if you're measuring something and it was 25 centimeters for sure, but it went a little bit past, you might say it's 25.5. Okay, you cannot say it's 25.53724. You're lying. You're making up stuff that you cannot measure. So when you take measurements, you make sure that you have the ones you know for sure, and you get to estimate one, and those are called significant figures. Okay, like this one. Okay, and this one, they recorded this as 22. And again, it fell right on the 2. But maybe somebody might say 22.1. This 0 is an estimate. Okay? For sure we know it's 22, but after that, maybe somebody will say, wait a minute, I don't think it goes all the way there. Maybe it's 21.9. Again, you have the 2 you know for sure, and then you get to estimate 1. Now here's a scale with more increments. Okay? And so instead of just saying, if I look on here, and I know it's hard to read, you guys, sorry, but 22.1, and then it went a little past, so we're saying it's 22.11. This one, I can have one more significant figure because it has more increments. It's a more accurate, if you want to say, scale. Okay, so it depends on what you're using to make your measurements. But again, you get to the ones you know for sure, and then you get to estimate one more. Those are significant figures. So this one would have 3, and this one would have 4. Okay, so because measurements involved uncertainty, we have to do, when you do a calculation, if you take 2 measurements and you do a calculation, let's say you're going to do density. The mass, you put it on the scale and it goes, 23.22. That's what it reads. That's what you write down. That has 4 significant figures. And then you do the volume, and the volume's 100. Okay. Now I'm going to do a calculation. I'm going to figure out the density. When I do a calculation, I have to make sure my answer has the same amount of significant figures as the answer, or when I get done with my calculation. I can't have more significant figures in my calculation than I did in the measurements that I took. If you do that, you're basically lying. Okay, so what are the rules? These are in your book. I'll go through them kind of quick, but we'll work on them some more. One thing to remember, if it's not a 0, it's significant, always. Okay, the number of some numbers have an infinite number of significant figures, like 12 inches are always in 1 foot. If it's an exact conversion, you guys don't have to worry about significant figures. Like there's 60 seconds in a minute. We know that. That's not something you have to worry about. I'm talking about when you take a measurement. Okay, zeros are the problem with significant figures. Okay, if it's not a 0, it's significant. But if you have any zeros in between non-zero numbers, like this 0 right here, is significant. So you count any 0 that's in between non-zeros. So far we know that if it's not a 0, it's significant, and if it's a 0 but it's in between non-zero numbers, it's significant. Okay, zeros are significant when if you have a number and you add a decimal point. Okay, like this, adding this 0 here doesn't really change the value of this number. But by adding that, by writing that 0 down, what it's saying is I measured up to that point. It just happened to fall on 0. Okay, why would I write it if I didn't measure up to it? Okay, so all of these are considered significant. So if you write zeros after the decimal, they're significant. Okay, when you have a number less than 1, until you get to a non-zero number, like these 3 zeros, they're just placeholders. They're not significant. These 3 are. And if I put any zeros after, they would be significant, because why would I write them? You know what I'm saying? Okay. And then if they appear at the end of a number without a decimal, okay? So right here, 6,920. All right. There's no decimal here. Adding a decimal says I measured and it just fell right on there. But if I don't write a decimal, it means that was kind of an estimation. So there's only 3 significant figures in here. That 0 doesn't count. Okay. When in doubt, if zeros are significant, use scientific notation. You can use that to help. But again, it's the zeros. if you're talking about here, how many significant figures? Well, 3.2, there's two because there's two non-zero numbers. Okay, and this one, because I took the time to write the decimal and the zero, they're all significant, so that would have 3. Okay, 103 people, I got a 0 in between, so all 3 of them would count. Okay, it's an exact number. Whenever you have an exact number, you count all of the numbers. In this one, it's a number less than 1, and so these zeros don't count. Only this one, so this would only have 1. Okay. The thing to remember when you do a calculation with significant figures, you have to round. All right. If you're using a calculator, you're going to get a lot, then the better our calculator, the more we get. So if your answer is 35.297634978, and you can only have 2 significant figures, you're going to have to do some serious rounding. So it's important, and I'm pretty sure most of you guys know how to round. 5 and above, you go up, 4 and below, you go down. And you have to do that when you're doing calculations with significant figures. Okay, and again, it explains it on the slide. I don't know if I really need to go through it, but it's important to round when you're doing calculations with significant figures. Okay, and again, you can go through rounding. So this one, round off the following number to the given number of significant figures. Well, okay, we can only have 4. So what I would do is I would write 79.14. I'd get rid of the 7 and round it up. This one, I can only have 3, so I'm going to take this 5 and round this, so it'd be 4.0435. Okay, and that one, I can only have 3, so basically I have to lose this 0.2. Okay, so again, when you do calculation with significant figures, you have to make sure you're going to round to make sure your answer has the proper number of significant figures. Well, there's another one. This one can only have 2, so I'd round this to 0.18. I'd lose this part and I'd round that 7 to 8. Okay, so when you do calculations with significant figures, your answer has to be as precise as the instrument, the least precise instrument. In other words, if I'm doing a calculation, let's say I'm multiplying 2 numbers, and one has 5 significant figures and one has 2, I have to make sure my answer only has 2, because that measurement that I took that only has 2, that's the least precise of my instrumentation. And again, we do this to make sure when we do a calculation, we're not lying. Okay? When you do multiplication and division with significant figures, it's based on, you look at each thing and how many significant figures they have. Okay? And then the one that has the least amount, that's what you have to round your answer to. Okay? So in this case, if I take 79.2 times 1.1, this is what you get when you multiply them together. This has 3 significant figures, and this has 2. So my answer can only have 2. So I'm going to look at my answer and I'm going to round this to 87. Okay? Because I can't have more than 2 significant figures in my answer, because this one only has 2. Even though this one has 3, this one only has 2, so you have to do that. Okay? If you round this, again, you do this calculation, you get 4.872. 4 significant figures, 2 significant figures, 2 significant figures. My answer can only have 2, so I'm going to go 4.9. Okay? Again, when you do the calculation like you normally would, and then you look at your answer and you round it to the one that has the least amount of significant figures. Okay? So the results of calculations, again, are only precise as the instrument that you're using. Okay, if you do addition and subtraction, it's actually really simple. It's just based on the decimal. Like if I added these numbers together, I'd add them together like I normally would. This goes 2 past the decimal, this doesn't go past the decimal, and this goes 1 past the decimal, so I'd have to round my answer so it didn't go past the decimal. Okay, so that would be my answer when I add them together. But again, this one didn't go past the decimal, so I'd make this 247. Okay, and you can't see that. My face is in the way, sorry. But it would be 247. Okay, I'm going to do a couple of these and then it's going to be 15 minutes, so sorry. Okay, so I subtract those, and again, my answer can only go 1 past the decimal. So if I, subtract these, I get 129.57, but I can't go, this only goes 1 past the decimal, so I round it to 129.6 right here. So yes, this is the exact answer, but that's it. And that's it. We're going to run out of time. So